Hello and welcome to a Simcenter Amesim Student Edition tutorial covering how to use the post-processing feature. Processing is a function that can be made available under Edit and then Show/Hide when in parameter or simulation mode. Here, parameters, variables, and user-entered values and expressions can be entered to do further analysis following a simulation. The model shown is seeking to find the heat transfer through an exterior wall with the temperature from the sun on the outside and air at a fixed colder temperature for the interior. To find a more detailed explanation for the components and the respective parameters for this model, please go check out the thermal wall tutorial after this. The total heat transfer can be found mathematically, following the steps shown, treating the problem as a thermal circuit. After finding the convective resistances on each side of the wall and the conductive resistance within, heat transfer can be found with the last equation. To validate the model's behavior with these equations, let's use post-processing. The area for the face of the wall can be found first, with the parameters for width and length entered into the thermal wall component, done by simply dragging and dropping them into the window. From here, a placeholder for the name and title are created. Changing these is as simple as double-clicking and typing them in. The expression determines the value for the item, which for parameters or variables will be its respective name at the component name, followed by conversions from the default unit to its current value. The default result set can be changed when working in batch studies. To display a value with a parameter or variable within the post-processing window, a simulation must be run first. So let's do that. With the length and width values recorded, a new post-processing variable can be created with a right-click and selecting Add, which will be to calculate the area, the expression for which will be the width variable times the length one, which can be done by using the names of each. The value can be displayed for this by pressing the refresh button at the top left of the window. Another needed value is the internal temperature, which is established by a global parameter. A global parameter can be entered into the post-processing window in the same way a regular parameter would be, with the expression being the name of the global parameter. The last way to create a new value is by bringing in a results variable, which is added in the same way as a parameter. This needs to be done for the convection coefficients for both of the exterior and interior sides of the wall. Variables or parameters can also be included with another post-processing variable to perform mathematical functions just by clicking and dragging them into the window and on top of the desired variable. Once placed, the available operations are present to choose from in a pop-up window. With all of these methods of creating a post-processing variable, the needed information and equations have been entered into the window to validate the thermal circuit equations given. For better organization, groups were created, done by right-clicking and selecting New Group, to store different parts of data by clicking and dragging them. To display the value of a variable for the span of the simulation, click and drag the variable into the sketch window, which will display a graph just like when displaying a results variable. Comparing the calculated value of heat transfer to the value from the simulation, with positive being heat transfer from the exterior to the interior, one can see that the values are the same. This shows how excellent post-processing can be to validate a model's behavior or extrapolate the results further. And with that concluding this video, thank you.